You ever been on one of those spinning carnival rides? Or maybe just taken a really sharp turn in a car and felt that powerful force just pinning you to the side? It feels like something is actively trying to throw you outwards. Well, today, we're going to tear apart the physics behind that feeling and uncover the secret force that's really running the show.
We all know that feeling, that powerful push outwards when we spin. But what if I told you that entire feeling is basically an illusion?
Think about a ride like the Gravitron, right? You feel absolutely plastered against the wall. It seems so incredibly obvious that some force is flinging you away from the center. But is that actually what's happening?
Yeah, an object moving in a circle seems to constantly want to escape outwards. That feeling is the central mystery we're going to solve today. And trust me, the truth is way more interesting than you might think.
Okay, so to crack this puzzle, we've got to understand the real physics of what keeps an object moving in a circle, and it all starts with what an object naturally wants to do.
Here's the absolute key to everything. According to the laws of physics, objects want to move in a straight line. That's inertia. Just picture it. You're spinning a rock on a string, and you let go. It doesn't fly straight outwards from the center, does it? No way. It shoots off in a perfectly straight line, tangent to the circle at the exact moment you released it.
So if everything wants to go straight, how do you force it into a curve? Well, you need a constant acceleration that is always pulling the object inward, toward the center. Notice here how the acceleration vector A is perpendicular to the velocity. That's the secret sauce. It doesn't change the object's speed, it only changes its direction, constantly bending that straight path into a perfect circle.
And that inward pull, it has a name, centripetal force. The word literally means center seeking. This is the real deal, the actual physical force that causes any and all circular motion. Without it, everything would just fly off in a straight line, period.
Now, the amount of force you need depends on mass, the radius, and the speed. But look closely at that formula. The speed is squared. This is huge. It means that if you double your speed, you need 4 times the inward force to keep you on the same path. That's why taking a sharp turn just a little too fast feels so incredibly intense.
So, we've established there's a real force pulling things in. Now, it's time to confront the ghost that we've all been feeling. This is the big one, right? If the physics says the only real force is center seeking, then what on earth is that sensation pushing you against the car door or the wall of that carnival ride?
And here's the answer, as clear as it gets. The so-called centrifugal or centriflaying force, it's not a real force. It's a phantom, a fake. Let's walk through it. As the car turns left, a very real centripetal force from the door pushes your body inward, forcing you into that curve. But your body, thanks to inertia, is desperately trying to continue in a straight line. So you feel yourself pressing outward into the door. That feeling, that apparent force, is just your own inertia resisting that change in direction. It's your body trying to go straight.
Okay, now that we've officially busted the myth, let's look at where this real center-seeking force shows up in the world around us. You'll see it's always there. It's just wearing different costumes.
This is really important to get. Centripetal force isn't a fundamental force of nature like gravity or electromagnetism. It's more like a job title. And that job can be filled by some very familiar forces that we already know about.
For instance, when you swing a rock on a string, what's pulling it inward and keeping it from flying away? It's the tension in the string, of course. In this case, tension is doing the job of the centripetal force.
When a car makes a turn, what's providing that inward pull? It's the static friction between the tires and the road. And this is exactly why, if the road is icy and there's not enough friction, the car can't make the turn and just skids off in a straight line, just like inertia says it should.
And now for the grandest scale imaginable. What keeps the Earth from flying off into deep space? It's the sun's gravitational pull. Gravity is constantly pulling the Earth inward, forcing its path to curve. So in this cosmic dance, gravity is playing the role of the centripetal force.
Okay, let's apply everything we've learned to one of the most exciting examples out there, the vertical loop of a roller coaster. Why do you feel so light at the top and like you're being crushed at the bottom?
The key is to always look at where the center of the loop is. When you're at the top, gravity is pulling you down, which is towards the center. So gravity is actually helping to make the turn. But at the bottom, gravity is still pulling you down, which is now away from the center. It's working against the turn.
So at the very top, both gravity and the force from the track are pushing you down, toward the center of the loop.
And since gravity is doing a lot of the heavy lifting required to keep you in the circle, the track doesn't have to push on you as hard. The result? You feel lighter, almost weightless.
But at the bottom, whoa, it's a completely different story. Gravity is pulling you down, away from the center. So the track has to push up with an enormous force, not only to counteract gravity, but also to provide the massive centripetal force needed to whip you back upwards. This huge upward force is exactly why you feel pinned to your seat.
So, from the spin of a planet to the thrill of a roller coaster, understanding that one simple secret, the inward pull, brings the full 360 degrees of motion right into focus.
And that's the real takeaway here. The next time you're in a car, on a ride, or even just watching your washing machine on its spin cycle, look for that inward force. What's providing it? And remember that the outward push you feel, well, that's just the ghost of inertia.